Hello again, everyone. This is Mr. B. Hill, and today we are going to be talking about simplifying algebraic expressions using the product properties of exponents. So there's three properties we're going to talk about today. The first one we call the product rule. And so this is what we use when we have a product of two exponential expressions using the same base. So we have, say, some value a, which is being raised to the power of m. We multiply that by that same base being raised to, say, the power n. Well, what ends up happening here is that's equal to a to the power of m plus n. So we're multiplying here. All we really have to do is add the two exponents together. That's how we do this actual multiplication by applying this product rule. And this is not something you should memorize. Do not memorize it. If you do, you're going to forget it, and then, trust me, I've seen it a million times before. But just look at a simple example if you forget how this works. Suppose you have, say, x to the power of 3, or multiplying that by x to the power of 4. Well, the whole rule, it comes out of the fact that an exponent is just a repeated multiplication. So x cubed, well, that's, of course, x times x times x. 3x's multiplied together. But then we're multiplying that by this x to the fourth. I'll make these two multiplications bigger so you can kind of notice that one. So x to the fourth is just x times x times x times x. So notice here we have a total actually of 7 x's being multiplied together. 3 from this expression, 4 from this expression. So this is just x to the power of 7. Pretty simple to understand when you look at it that way. Just take a basic example and no problem. The idea is that people tend to get this confused with the next rule we're going to talk about, which is called the power rule. But just for the product rule, also, and it works for negative exponents as well. Just look at a really simple example like, say, x to the power of negative 3 times, I don't know, x to the power of 5. Well, remember how negative exponents work. X to the negative 3 is 1 over x to the power of 3, and that's being multiplied by x to the fifth. And of course, now we have in the denominator x cubed, or x to the power of 3. That just means in the denominator we have x times x times x. Still multiplying it by this x to the fifth, but this x to the fifth is, of course, x times x times x times x times 1 more x. And if we want to make our multiplication with these fractions a little bit simpler, we can just put that over a factor of 1. So doing the multiplication, of course, numerator times numerator, x times x times x times x times x on top, and on the bottom, x times x times x. And of course, what's going to happen here is that these 3 factors of x in the denominator will cancel 3 of the factors of x in the numerator, leaving us just with x squared in the numerator. Over 1, but you don't have to put that in. And of course, negative 3 plus 5 is, of course, this exponent of 2. Next rule we're going to talk about really quickly is what's called the power rule. So the power rule, well, that's what happens. Well, this is how we will deal with it when you have, say, a raised to the power of m, but then we raise that expression to another exponent, say to the power of n. And what happens here is basically you just multiply the two exponents together. So this would be a to the power of m times n. We just multiply these two exponents together. And again, not something to memorize. Just work a simple example. Suppose we have x cubed, but then we want to raise that to the power of, say, 4. Pretty simple. X cubed is, of course, x times x times x. And that's going to be raised to the power of 4. But this is just now 4 copies of this x times x times x, all being multiplied together. Now, all of this is multiplication. There's nothing else going on in this expression now. So the associative property of multiplication says that we can just drop those parentheses. They don't really mean anything anymore. So this is just x times 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 x. A lot of x's. Well, how many? Well, of course, we have 12 of them here. 3, 6, 9, 12. So this is just x to the 12th. And of course, 3 times 4 is 12. So you have 4 sets of these 3 x's, 12 x's multiplied all together. And again, not anything to memorize, just work a simple example if you forget the power rule. And it also is going to work for negative exponents. Suppose we have x to the power of negative 3, and then we raise that to the power of 4. Well, x to the power of negative 3 is 1 over x cubed. That's being raised to the power of 4. Sorry about that. So this would be 1 over x times x times x times 1 over x times x times x times 1 over x times x times x times 1 over x times x times x. So when we do this multiplication, of course, numerators get multiplied together, denominators get multiplied together. So the numerator is just a 1, and then on bottom, well, we see these 12 x's being multiplied all together here, which is, of course, just 1 over x to the 12th, which is actually the same thing as x to the power of negative 12. And we see that negative 3 times 4 is, of course, negative 12. Now, to completely simplify, we don't want to write anything with this negative exponent, so we'd want to write it this way, as 1 over x to the 12th. And that's the power rule. Finally, we have what's called the product to a power rule. And of course, like the name implies, this is when we have a product, a times b raised to some exponent, say m. What happens with this? Well, that's just a to the power of m times b to the power of m. Notice this exponent gets applied to each of the factors in this product. Basically, this is what I like to call the distributive property for exponents. So an exponent will distribute into a product. This is the same way that a multiplication will distribute into a sum using the distributive property. What we normally call distributive property, right? But now, of course, an exponent will not distribute into a sum. We'll get back to that in just a little while. But again, if you forget this, just work a simple example. Suppose we have x times y raised to the power of 4. Well, that is just x times y times x times y times x times y times x times y. And again, by the associative property of multiplication, these parentheses don't actually mean anything. We don't need them in there. X times y times x times y times x times y times x times y. Then by the commutative property of multiplication, we can jumble these factors up however we like. So let's just move all the x's to the front, x times x times x times x, and move all the y's to the back, y times y times y times y. And of course, now we have 4 x's multiplied together, which is x to the 4th, multiplying by 4 y's being multiplied together, which would be y to the 4th. So we see this exponent is now getting applied to both factors in this product. And those are your 3 rules. Let's get a little bit of practice here, There's 2 practice problems for you. I encourage you to work through those and then maybe talk to some of your peers to see if they're getting the same simplified expressions.